Hello everyone. Today we are going to explore something really important in SAR data analysis: ascending versus descending orbits in Sentinel-1 and why geometry actually matters. If you're working with Google Earth Engine or using VV and VH polarization, this video will help you understand things much more clearly step by step, from data loading to compositing to orbit, difference, and finally how to interpret everything correctly. So first, we define our region of interest around Kolkata using a 30 kilometer buffer. And then we center the map so that the entire study area is clearly visible. Next, we load Sentinel-1 data. But here comes the key idea. We separate the data set into two different orbit passes: ascending and descending. Ascending means the satellite is moving from south to north, while descending means it moves from north to south. And even though the location is exactly the same, the viewing geometry is different, and that difference directly affects the SAR backscatter. Now comes a very important step: compositing. And this is where many people make mistakes. We do not directly average values in decibel. Instead, we first convert the data from decibel to linear scale, then take the mean and finally convert it back to decibel. This ensures that our SAR values remain physically correct and meaningful. After that, we calculate the orbit difference by subtracting descending data from ascending data. And this helps us understand where and how the satellite sees the surface differently just because of the change in viewing direction. Then we create a combined composite where we merge both ascending and descending data. This is very useful because each orbit has its own blind spots, and by combining them, we get a more complete and reliable SAR representation. Next, we calculate the incidence angle for both ascending and descending passes. And this is actually the core reason behind all the differences we observe, because SAR backscatter is highly dependent on the angle at which the signal hits the surface. Now let's understand the outputs one by one. Output 1. Ascending VV. The image shows backscatter from the ascending orbit. Here, black areas represent low backscatter, like water or smooth surfaces, and white areas represent high backscatter, like urban structures or rough terrain. In output 2, descending VV. The same color interpretation applies. Black means low backscatter, white means high. But if you observe carefully, some areas look different compared to ascending. And that difference comes purely from the change in viewing direction. In output 3, combined VV. Both ascending and descending are merged, and as a result, the image looks more balanced. Missing details from one orbit are filled by the other, giving a more complete picture. In output 4, VV orbit difference. This is one of the most important visualizations. Here, red color indicates that ascending orbit has higher backscatter, blue indicates descending has higher backscatter, and white means both orbits agree, U. We'll notice that urban areas show strong red and blue variations because of building orientation and layover effects, while water bodies remain mostly white since both orbits see them similarly. Moving to output 5, ascending VH. This represents VH polarization in ascending orbit. Darker areas indicate less vegetation or smoother surfaces, while brighter areas indicate vegetation or structural complexity. In output 6, descending VH, the same interpretation applies, but again, differences appear due to orbit geometry. In output 7, combined VH, we get a more stable and complete vegetation representation with reduced noise and better coverage. Then in output 8, VH orbit difference. Red means ascending is stronger, blue means descending is stronger, and white means both are similar. This mainly reflects differences in vegetation structure and scattering behavior. Now coming to output 9, ascending incidence angle. Here, green represents low incidence angle, yellow represents medium, and red represents high angle. And finally, output 10, descending incidence angle, follows the same color scheme, green for low, yellow for medium, and red for high. And this variation in angle between ascending and descending passes is actually the main reason behind all the differences we observed earlier. So, the key takeaway is, even for the same location, changing the orbit changes the SAR response. Urban areas show the strongest differences. Water shows almost no difference, and combining both orbits gives the most reliable and complete result. So that's it for today. If you found this video helpful, don't forget to like, subscribe,